We are now going to look at what happens to the period of a cosine function when there are vertical shifts or other modifications to the function. In other words, if we have f of x equals a cosine of a bx plus c plus d, does the period depend on b only, namely absolute value of 2 pi over b as we demonstrated before, or does the a, c, and d have anything to do with it? Let's take a look at some graphs. So here is our cosine function. We can see from the crest of one wave to the other, the distance between these two crests is 2 pi. So what happens when we change some things? First of all, we know that if we change b, it will change the period of the function. If we change it to 2, the new period is absolute value of 2 pi over b, which is now just pi. That's the distance between the waves. But what happens when we change, say, the number in front of cosine? What if we make it 2? Well, if we make it 2, notice it does nothing between the distance between the crest of these waves. It's still 2 pi. If we make it 3, 4, or 5, it does nothing. If we make it negative, it still does nothing. The distance between these is still 2 pi, no matter what, or between these 2 points, doesn't matter, wherever the graph repeats itself. So A has no effect. B does. We've already demonstrated that. How about C? Well, if you change the number that you're adding to x, all that does is shift the graph to the left and right. And again, this is great because this is a lesson we're going to look at later when we do function transformations for any type of function, not just cosine and sine. And then finally, D, all the D value does is it moves the graph up and down. It does nothing about the difference or the distance between these two points on the graph where the graph repeats itself. I'm going to change C just so we can have a kind of a definitive point. Let's just move it back here. But again, if we move D, no matter what, the distance between these is still 2 pi. That has everything to do with the B value. Okay, the second that the B value changes, this spring compresses or stretches, and therefore the period changes. So let's look at a formal proof for cosine. We've already looked at sine. If f of x is equal to a cosine of bx plus c plus d, and by the way, this is the same exact proof as sine, so I'm not going to spend as much time on it. If we plug in 0 for x, and by the way, make sure to watch the video, we get 0 plus c inside, and we get c. So we get f of 0 is equal to a cosine of c plus d. That's as simple as we can get with the y value at 0 when we have introduced a, c, and d. It's equal to a cosine of c plus d. That's the y value when we plug in our first x value of 0. We know that when we plug in 2 pi over b, we're going to get the same y value back. We've done that in the previous proof where we've shown that the period of cosine of bx is absolute value of 2 pi over b. So and that's because it just cancels the b's and you're left with 2 pi inside the angle. And we know that that's only when cosine repeats itself. Again, here's cosine of 0 and the x value is 1. It takes 360 degrees or 2 pi rotation before we get that same x value of 1 and the x values repeat themselves. So if we plug in 2 pi over b in for x, the b's cancel and we're left with 2 pi plus c. We did this proof in previous proof for cosine. If you take any angle and you subtract 2 pi from it, you end up with the same angle. So basically what I can do is I can replace this with this, okay? And I probably used the wrong colors here. We'll keep 2 pi plus c as our angle, but if we subtract 2 pi, we end up at the exact same angle, no matter what 2 pi plus c is. Say c is pi, then it's 3 pi, right? Well, we know that 3 pi minus 2 pi is still the same exact, it's not the same angle, but it gives you the same cosine value. So let's take a look. So for example, let's just do 3 pi. So 3 pi would be right here, right? If I subtract 2, so here's my x value, negative 1. If I subtract 2 pi, I go clockwise 360 degrees, and I'm back at pi, and voila, I've got the same x value. And that's going to be true for any x value on the unit circle. So I can replace these purple parentheses, 2 pi plus c, with 2 pi plus c minus 2 pi, since the cosines are going to be the same at both angles. And now, just like in the cosine proof, the 2 pi's are going to cancel 2 pi minus 2 pi, and we're just going to be left with plus c inside. So we get f of 2 pi over b is equal to a times cosine of c plus d. which is exactly the same y value that we got at f of 0. And we've proven that the graph repeats itself there. So, since the graph repeats itself from 0 to 2 pi over b, then the a, c, and d don't matter when you add them to cosine. And therefore, the period of any function where g of x is equal to a cosine of bx plus c plus d is just the difference between these x values, since the y values are both a cosine of c plus d. The distance between 2 pi over b and 0 is just the absolute value of 2 pi over b, and that, my friends, is the period of any cosine function with these a, b, c, and d values. That's it for this example and proof. If you have any other questions about this, let me know.